Okay, so this is our first example of induction involving inequalities. So the good news is we follow the same steps. So we begin by writing Pn, and then this is just us literally repeating the question. So just rewriting the question. We then do prove P of. Now, usually we use 1, but here we have a condition that we have to pay attention to. N is bigger than or equal to 2. So the lowest number I can pick is 2. So we fill 2 in and we make sure that this is true. So we get 9, 6 and 1 is 7. So we get 9 is bigger than 7. And that is, therefore, tick, that is true. So that's exactly what we wanted to happen. We then write our assume sentence, assume pk. So anywhere there is an n, we now put a k. And then we write our prove pk plus 1. So anywhere there is an n, we now have a k plus 1. So anywhere there was an n, we now have a k plus 1. So I'm just going to tidy that up a little bit more. And we end up with 3 to the power of k plus 1 is bigger than 3k plus 4. Now, this is where the steps that we wrote the last day come in. So it says what you want to prove is p of k plus 1 sentence. So we have that. What we assume is the pk sentence. So we have that. Now, this is the absolute key sentence. How do we change assume to match prove? So what I'm going to do using my highlighters is we are going to try to make the yellow somehow into the pink. So in other words, we need to figure out a way to make our assume sentence look like our prove sentence. And the key step here is understanding this. If you see 3k plus 1, you need to understand that's the equivalent of 3k multiplied by 3 to the power of 1. So to make the yellow into the pink, all I really have to do is, in fact, triple the 3 to the k. Now, if I triple the left, I have to triple the right. So that is why my right-hand side is also times 3. So I can now write this to look like the pink. And I just tidy this up a little. So 3 by 3 is 9. 9k plus 3 times 1 is 3. Now, this is what I call my adjusted assumption. Adjusted assumption. So we started with an assumption, but now we have adjusted it. We've changed it. To finish it, we need to write the following. This is true if. Now what we do is, and again, I have the sentence written above here. It's true if the adjusted assume is bigger than the prove. So we're going to write down, it's true if the adjusted assumption, the 9k plus 1, is bigger than the prove being 3k plus 4. Now, looking at this, do we know immediately that it's true? Well, we do really, because we know that n has to be bigger than or equal to 2, which means k, which replaced n, has to be bigger than or equal to 2. So let's say we do try 2. If I try 2 in here, I soon find out that 18 plus 3 is bigger than 6 plus 4. In other words, 21 is bigger than 10. That's obviously true. So it's true if it works, and it is true as, or true because, k is bigger than or equal to 2. So what we usually do now is we repeat the last black sentence just to kind of clarify that we have proven what we wanted to prove. How did we do it? Well, we did it using the green and the orange section. And then we go ahead and do our usual generic line. Therefore, p of k plus 1 is true if pk is true And then this implies that P of n is true for all n is an element of n. Now we do have to include the restriction where n is bigger than or equal to 2. So don't forget just to include that last detail.